Thank you. Welcome. Um, my name is Tsietsi Philip Majele. Today I'm going to take you through the topic whereby I will be discussing attributes. As you see on the screen, mainly attributes in the perspectives of data mining or in the field of data mining. I hope you watched some of my tutorials where I was explaining processes and data mining. So as you can see, what is an attribute? It can be seen as a data field that represent characteristics or features of data object. For a customer object, attributes can be customer ID, address, etc., maybe names. We can say that a set of attributes used to describe a given object are known as attribute vector or feature vector. We have different types of attributes. So basically, when I try to explain what we mean about attribute, what is an attribute? An attribute is a data field representing a characteristics or feature of data object. The nouns attributes, dimension, feature, and variable are used interchangeably. So mainly the term dimension is commonly used in data warehousing. Machine learning literature tends to use the term feature, while statisticians prefer to use the term variable. Data mining and database professional, they commonly use the term attribute. Attributes describing a customer object, like I said earlier, it can include the customer ID, like the customer address, customer name, customer surname, and many more. So like I said, they can be known as attribute vector or feature vector. This is the first step of data pre-processing. We differentiate between different types of attributes and then pre-process the data. So here is the description of attributes types. Qualitative, which involves nominal, and ordinal, O, and binary. Quantitative, discrete, and continuous. I hope we are still together. So let me start by describing these different types of attributes, starting with the nominal attributes. What is the nominal attribute? Nominal means relating to names. The values of nominal attributes are symbols or names of things. Each represents some kind of category. It can be a code or a state. So nominal attributes are also referred to as categorical. The values do not have any meaningful order. So in computer science, the values are also known as enumerations. Let's make an example so that you can understand what are the nominal attributes. Suppose that hair color and marital status are two attributes describing a person object. So in our application, possible values of hair color, it can be black, brown, blonde, red, gray, or white. Or the marital status can take on the values like single, married, divorced, widowed. So both the hair color and the marital status are nominal attributes. So another example can be the occupation, with the value teacher, dentist, programmer, farmer, designer, and so forth. These are the list of the nominal attributes. So we can continue and talk about binary attributes. What are the binary attributes? Binary attributes is a nominal attribute with only two categories or states, which is 0 or 1. You understand that? So let me repeat that so that you can get it right. A binary attribute is a nominal attribute with only two categories or states, 0 or 1, where a typical 0 means that the attribute is absent and 1 means that the attribute is present. Binary attributes are referred to as Boolean if the two states correspond to true or false. These are the binary attributes. So we can just come and make a simple example in the binary attributes. Given the attribute smoker describing a patient, 1 indicates that the patient smokes, while 0 indicates that the patient does not smoke. Another example is in the fraud detection system. 1 can represent that there is a fraud, while 0 can represent the transaction that is non-fraud. Another example can be maybe in a situation whereby we want to determine or we are looking at the medical test outcomes. So the medical test outcomes can also be binary, where a value of 1 means the result of a test for a patient is positive, while 0 means the result is negative. So a binary attribute can be symmetric if both of its states are equally valuable and carry the same weight. That is, there is no difference on which outcome should be coded as 0 or 1. So one such an example could be the attribute gender, having the states male and female. Hello? I hope we are still together. So a binary attribute is asymmetric if the outcomes of the states are not equally important, such as the positive and the negative outcomes of the medical test for HIV. So by confession, we quote that the most important outcome, which is usually the rarest one, by 1, HIV positive, and the other by 0, which is HIV negative. So we have done with the binary attributes. Please, while you are watching this video or tutorial, then don't forget to click like or subscribe on my channel so that in the future, when the new videos are being uploaded, then you can have. So now we are done with nominal attributes. So now it's time for us to go straight to ordinal attributes. So we are still trying to explain these attributes in the field of data mining. So an ordinal attribute is an attribute with possible values that have a meaningful order or ranking among them, but the magnitude between the successive values is not known. Okay, let me make example so that you can understand. So suppose that the drink size correspond to the sizes of drinks available at the fast food restaurant. This nominal attribute has three possible values, which are small, medium, and large. Small, medium, and large. So the values have a meaningful sequence which corresponds to the increasing drink size. However, we cannot tell from the value how much bigger, say, a medium is more than large. Other examples of ordinal attributes can be grades, maybe A plus, A minus, B plus, C plus, and so forth and so forth. Even the professional ranking also, like maybe in the military, private first, specialist, the corporal, sergeant, or all those rankings in the army. So we can also come up with another example whereby we can talk about the customer satisfactions. So we can categorize our ordinal attributes in the form of 0, 1, 2, 3, 4. Possibly we can say when it's 0, the customer is very satisfied. 1, somewhat dissatisfied, or 0 is dissatisfied. You understand that? So 1, somewhat dissatisfied. 2, maybe neutral. 3, fully satisfied. 4, very satisfied. So this is how we can categorize our ordinal attributes. So another type of attributes can be numeric attributes. A numeric attribute is quantitative. That is the numeric attribute is quantitative. So that is, it is measurable quantity represented in integer or real values. Numeric attributes can be interval scaled or ratio scaled. So what do we mean when we talk about the interval scaled attributes? The interval scaled attributes are measured on a scale of equal size units. The values of interval scaled attributes have order and can be positive, 0, or negative. Thus, in addition to providing a ranking of values, such attributes allow us to compare and quantify the difference between the values. Interval scaled attributes, example, can be a temperature. Temperature attribute is interval scaled. Suppose that we have the outdoor temperature value for a number of different days, where each day is an object. By ordering the values, we obtain a ranking of objects with respect to the temperature. In addition, we can quantify the difference between values. For example, a temperature of 20 degrees is 5 degrees higher than a temperature of 15 degrees. Calendar dates also can be, for instance, 2002 and 2010 are 8 years apart from each other. So we come to ratio scaled attributes. A ratio scaled attribute is a numeric attribute with an inherent 0 point. That is, if a measured is ratio scaled, we can speak of value as being multiple or ratio of another value. In addition, the values are ordered, and we can also compute the difference between values, as well as the mean, median, and mode. So for example, we can talk about the Fahrenheit, Celsius, and Fahrenheit temperatures. Scale that has what is considered as a true 0 point, which is 0 degrees or 0 Kelvin, which is equals to negative 273.15 degrees. It is the point at which the particles that the compromised matter have 0 kinetic energy. So we can talk about another example of a ratio scaled attributes, including count attributes such as years of experience, e.g. the objects are employees and the number of words, the objects are documents, the number of words. These are the examples of our ratio scaled attributes. So coordinates also, like clustered houses, monetary qualities. You are 100 times richer with $100 than with $1. So these are the different attributes. So now we can go straight and talk about the discrete versus continuous attributes. So when we talk about these two attributes, we can say a discrete attribute has a finite or countable infinite set of values. It has a finite or countably infinite set of values, which may or may not be represented as the integers. You understand that? Which may or may not be represented as an integers. And the attributes hair color, smoker, medical test, drinking size, each have a finite number of values, so are discrete. Note that attributes may have numeric values such as 0 and 1 for binary attributes, or the values are 0 to 100 for the attribute H. An attribute is countably infinite if the set of possible values is infinite, but the values can be put in one-to-one correspondence with the natural numbers. For example, the attribute custom ID is countably infinite. The number of customers can grow to infinity, but in reality, the actual set of values is countable, where the value can be put in one-to-one correspondence with the set of integers, like the zip codes is another example. If an attribute is not discrete, it is continuous. The terms numeric attribute and continuous attribute are often used interchangeably in literature. This can be confusing because in the classic sense, continuous values are real numbers, whereas numeric values can be either integers or real numbers. In practice, real values are represented using a finite number of digits. Continuous attributes are typically represented as floating variables. So this is the end of our presentation on attributes. So next we are going to discuss the basic statistical description of data and go through maybe the measuring central tendency, like mean. How do you compute mean? How do you compute median? How do you compute mode? So by so saying, stay tuned. Please don't forget to subscribe for more video tutorials. Thank you so much. See you on the next video. Bye.